Welcome to our presentation. We are Group 8 presenting on fossil fuels' disproportionate effect on marginalized populations. My name is Walker Dockery.
My name is Jack Curtis.
My name is Jerónimo Escobar.
My name is Kai Manick.
And my name is Felix Burdine.
The populations that we found to be most impacted by our current over-reliance on fossil fuel burning power plant units are specifically American Indian and Alaskan Native, as well as Hawaiian Pacific Islander communities that live on federally recognized reservation land that falls within roughly 3 miles of or exists downwind of any sort of fossil fuel burning power unit. Due to the mass loss of land belonging to Native populations, they've been pushed onto areas that fall on generally cheaper taxed land that power companies take full advantage of to maximize their own profits. It's also not uncommon for these groups to live on land that lacks affordable quality housing that can protect them against the natural weather events that are often linked back to being caused by the emissions produced by any sort of fossil fuel burning power plant. Moving on to the challenge statement, the problem that we intend to address with our campaign and design is the exposure of pollutants on the previously stated populations due to the reliance on greenhouse gas emitting power sources such as coal power plants in the U.S. There's a large quantity of these plants in the U.S., especially in areas that result in certain populations being more susceptible to their impacts. With our solutions, we intend to raise awareness in order to raise public appeal and potentially change governmental policy regarding these issues, as well as gain research data that will allow us to target the areas most affected by these pollutants. Overall benefits that our solutions can provide are as follows: reduction of pollution and its impacts on disadvantaged populations, increase of renewable power, specifically that of fission and fusion, and less reliance on potentially dangerous and unsustainable power sources.
So as mentioned in our benefits, our focus is on the grand challenge of providing energy from fusion in relation to this. And that shows up in our solution brief, which comes in two main formats. First of all, our main focus is going to be a multi-branch campaigning effort that advocates for additional funding for and destabilization of these future power plants so that they can continue in their research and become a formidable power source that can replace what already exists as greenhouse gas emitting power plants like coal. And our second part of our solution is a product that is associated with the endeavor, which is an all-in-one tool capable of measuring toxic pollutants in the air, water, and soil, which we intend to raise funding for to send to the areas that are able to utilize them best, so we can gather research to continue adding to our campaigning effort and hopefully eventually replace these coal power plants with fusion.
The largest part of our feasibility study was actually analyzing the feasibility of our air quality measurement device. Within this feasibility, we determined a total cost of approximately $68 to $80 per unit. This is broken down into the raw material costs, which we determined that we were going to use ABS plastic for the housing, manufacturing costs for injection molding, filters for the internals of the unit, the motor that drives the turbine, as well as LCD screens and other miscellaneous expenses in the production of it. To highlight what our design looks like, we have a 3D model as well as an orthographic projection drawing showing all of the nuances of our design. We wanted to make sure the design was as cheap but also reliable in taking data measurements as possible, and we believe that we achieved that very effectively.
With regards to the existing technology that aims to address these problems that we brought up, there are kits for water contamination, air contamination, and soil contamination. Some of them are take-home kits where someone can purchase them and use them at their house and get the results instantly. Others, you get a sample and you send it to a lab. However, there's no product on the market that combines all of these into one portable, reliable product, which is what we aim to do.
Though the design works as intended, it is still not ideal. It still requires adjustment and to lower the price, to make operation easier, and to reduce safety concerns associated with the spinning blade. In terms of feasibility, we identified specifically 3 shortcomings that limit how practical the device is at a larger scale. One of the first shortcoming, using pre-engineering parts in our design, as this will raise the price. The second issue is the technical learning curve required to properly use the device. A steep learning curve limits usability because it slows down how quickly someone can understand and apply the device in any situation. As for the final shortcoming, it's the potential safety hazard associated with a spinning blade. This component can introduce risk. The spinning blade is not just a physical risk. It also creates legal demands and obligations for any product intended for public use.
So the next steps with this project is we're going to apply this product
to our solutions. And what we're going to do is we're going to use this product to gather data in these disadvantaged communities that prove the extent of this issue. And now that we have proven that this is an issue, this is harming these populations, hopefully this data will gather public support. And we need this public support for our campaigning, which is one of the steps of our solution. So we get the data, we get public support, and we get people to support our campaign. And once that happens, we'll be able to achieve the goals of our campaign, increase the output of nuclear fusion energy and fission energy, which will decrease our reliance on coal-fired plants. And then hopefully we can phase out of coal-fired plants in total and replace these coal plants with fusion plants at the same site, taking advantage of the pre-existing infrastructure in that spot. Our end goal with this whole process is to have commercially feasible nuclear fusion plants in these same places as the coal plants. And this will free these historically disadvantaged populations from the environmental hazards that come from coal energy.